the session is all about the operating system structures. Okay, what is the meaning of structure? So whatever the basic need of the services that has to be provided, okay, started to gradually develop since 18th centuries. There was only a limitations to provide the interfaces to the device drivers. Okay, and as we went on to the next century era of 19th century, there was a bit change with the structure of the or the design architecture of an operating system. So today we will deal with what are the different categorizations of the operating system structures. Okay, so what would be the objective behind considering any design of an operating system structure? The main objective has to be that it shouldn't be more complex in nature, means whatever the structure or the design that we develop shouldn't be more complex in nature, and it should at most be taking care, okay, in such a way that in further way it has to be easy to modify the particular design content. So first one is it shouldn't be complex in nature. The second thing is it should be more feasible to modify a certain design, whatever the structure that is being developed. And the other point is, whenever we create any operating system, it should be more defined with what is the type of input that we are giving to the particular system, what is the output that we are gaining, and what are the various functional requirement or the resources that is being adopted in an operating system. So this has to be the objective in order to design any operating system structures. So on the basis of the objectives, so we have the different type of structures that has been categorized into. The first one is the simple structure, the second one is the layered structure, and third one is the micro kernel structure, and finally a modular structure. Okay, so let me go straight away with the simple structure. Simple structure started from the era of the late 18th centuries. Okay, so what was the strategy of the simple structure was, given any minimum input was always from the device driver ends, in the sense it was with regard to a hardware device driver end or with a certain set of the files that was already been adopted in an operating system. So what was the main role play of the simple structure was, any single task was being supposed to be played by an operating system, and all the files of interfaces were being saved in the ROM BIOS device drivers in order which has been adopted from the resident system program, means which is already been added into the setup file or the primary memory of an operating system. Okay, and application end user used to interact using the application interfaces. Okay, so as we already know, what is the full form of MS-DOS is? It is Microsoft Disk Operating System. That was the initial starting step of the Microsoft company sectors, who started to initially develop a simple structure of an operating system. Okay, the disadvantage of this particular operating system was, it wasn't more feasible in order to take a multiple task. Whenever there was a multiple task that was being adopted to the interface level or to any request raise level, there was a crash or there was not a proper response from the operating system. So that was a major disadvantage of a simple structure. So after that, after the late initial 19th centuries, we started to know about the operating systems structure strategies, started to design and come with a new innovative idea that was with regard to the layered structure. Okay, this is layered structure. Okay, so what is layered structure? A layered structure was any set of setup files which is doing a same task, in the sense It can be with regard to a hardware interrupt like device driver interrupt, or it can be with regard to the same set of files which deals with editing of a text. Let us say it can be with the notepad, it can be Microsoft Word, or it can be Microsoft Excel, which is generally all about a request that has been raised in order to edit some text formats. So a similar set of programs or executable set of files were commonly considered as a layer. Okay, were commonly considered as a layer in this particular architecture, which is a layered structure. So, and it was being segregated and it was being given a priorities on its request that has been raised, or on the basis of its responses, resources response. Okay, so the first layer that was being considered was a hardware request, and as on the last that was being given was a user interface. It is just a representation that has been done with regard to a layered structure. Okay, so this is the approach that the design working sector people try to have a strategy on. But the disadvantage of the layered structure was that if there is any abrupt or if there is any fault of error that is happening in any intermediate layers, okay, so the raise of request was again should be started from the base level, that is the layer 0th level. Okay, if any intermediate error that happens at intermediate layer structures, okay, there used to be an issue that all the raise of request should again be bypassed from layer 0 followed by layer 1 and so on till the end layer service. Okay, so that was the problem that was being arrived with the layered structure. Okay, and you can see, if I want to tell the way or the diagrammatical look of a layered structure, it is something like a cake format. If you see that in the bottom, we say it also has a cake format structure. Okay, the layer structure is also being called as a cake format structure. Okay, so the advantage was that all individual same set of requests were separately segregated into layers. The very foremost disadvantage that was that though it was not having any problems with taking up a multitasking request of jobs, but the problems that was arising was with regard to the intermediate error fault. When it happens, it has to pass all the way from level 0 to the end service level. So this is all about the layered structure. Then let us go to the microkernel structure. Okay, what is the concept of microkernel structure? Microkernel, in the sense, it is not a small kernel. Okay, it is the name given to the structure or the design strategy. What is the design strategy of the microkernel structure is, okay, as always been said that there is always been said that microkernel is always an intermediate between a hardware, okay, all the device drivers or a software, and to the user mode end. Okay, so here what is the strategy that has been adopted with the microkernel structure is, all the rays of requests and responses, most of the follow-ups of address space allocation, memory management, and storage management, process access management, all the works of priorities will be maximally spaced to the user mode. In the sense, all the priorities will be given to the user end level. Okay, you can see in the diagram that there is a user mode, and that user mode is easily bypassing the resources what is being provided by the kernel mode. It can be CPU scheduling, it can be memory management or space or storage management, whatever it is. It can be interprocess communication. You can see there is something messages that has been there in a diagram. What is the meaning of that messages is, if there is multiple user or the multitask that has been happening, the user mode has all his access space in order to interact among the task that has been there, or he can intermanage the devices by passing the sharing of the system. Okay, so all the probable of criteria or the way of approach will always be given to the user mode. So that is the microkernel structure. Okay, there is also something called as a monolithic structure. Okay, you can just note down monolithic structure, wherein the priorities of the entire raise of request will always be taken care by the kernel mode. All our recent system, the operating system that is coming, it is a monolithic structure. Okay, what is the example of microkernel structure is, you would have used the very old Windows DOS prompt. Okay, we had something called as Windows NT, Windows New Technology Operating System, wherein there were very limited services at that time. During the mid of 90s. Okay, there were very limited services of setup files, and all the setup files used to be taken care by the user end, means by raising a request to command line prompt. All most of the works used to be done by the user end. There was very less work that was being done by the kernel end. So that's the reason we call it as a microkernel structure. Okay, so let me just open that particular slide for you all to be more emphasized on the content as been said. Let me just read the last point. Windows NT, which is usually a best example that is being considered for a microkernel. Okay, where here the lag of this microkernel structure is certainly with the reliability and the robustness, because as every work or the raise of request and the response is taken care by the user mode end, there will be certainly a lag of the robustness and the performance of the system, which has been in turn made possible by changing the structure with monolithic. Okay, so this is all about microkernel structure. And the last structure which I want to talk about this modular structure. Okay, I've taken an example of a Solaris system, which is a type of Linux system. Okay, here you can see that it is somewhat the similar way of approaching with combination of the microkernel and the layered structure. What is the way that the modular structure has been approached is that every similar set of execution format, okay, is considered as an object here. The scheduling class is an object, device and bus driver is an object, stream module is an object, which is commonly attached to one central object called as a kernel. Okay, here, as wherein the similar objects were set up into a layer in the layer structure, here all the similar set of contents are being different, is being considered as an object and is being commonly added to a interlinked to a kernel. Here, the advantage of the modular structure is that any objects can be intercommunicated, because there is an intermediate to all of the objects here. The kernel is an intermediate to all the objects that has been raised a request to. So device and bus drivers has intermediate to executable formats. Load and system calls has a intermediate to miscellaneous modules. In a sense, there is a proper interconnection among the objects when it comes to the modular structure. Okay, this is all about the this is all about